Welcome to the 2026 networking competition. So let's get started. Make sure if you join this live, make sure to comment, and hoping to see you live there so that you watch our participants. Welcome to the 2026. Okay, so first thing first, let's make sure that everything is intact. So we would like first to congratulate everyone who managed to make it in the official 2026 networking competition. And yeah, let's make sure we see which teams have registered for this competition and so on. So let's start off with the teams. So right now, under the live events, we need to see this particular event here, which is taking place. So 8 minutes to go. I'm not sure if they've extended the time, but all you know, so far we have 11 teams of players. So let's see. So the first team we have MSB Networking Innovators. So here we have 2 people, and also one of my favorite students for this year is part of this particular group. So we have Prosper Simwinga and my boy Fiperwa Museva, hoping to see their wonderful performance, and hope they will do their own very best, because this is not simple, but competing among great students, you also need to be among the great. So we also have 0 subnet. I'm not even sure if that's the thing. Do we have 0 subnets? Okay, so we have 1 member, Clive Mumba. So hoping the best to this particular participant. Then also have Vemos Twins. What's that? Vemos Twins. So we have Emmanuel Monga. He's just alone. We have Villain Vipers. So we have Grace Chichilonga. So far the only female I've seen, and she's consistent. She participated in the first ever KMU CTF event. She also participated in the in last year's networking competition, and she's also participating in this one. Hope to see her also in the next upcoming event. Then now we have Joseph Mutale. So this guy is just alone. All the best to him. Then we have the Night Gamers. So these guys, so far, this is the biggest group in terms of these participants. So there are the 3 of them. So hoping to see their wonderful performance. Shout out to Jim Yoram, Jack Joshua, and Deti Sok. So hoping to see you great performance in this particular event, and all the best. So as we are waiting for the event to start, let's see what are some of the prizes for this particular competition. So the first place will walk away with a 300 kwacha. Then second place it will be a 200 kwacha. So making it total 500 kwacha, which looks like a small amount, but because it's a free event and we are just here to make sure that we upgrade our skills in terms of networking. So it's a good thing that we are also giving some particular prizes for this particular competition. So all the best again to the participants, hoping to see your great performances there. So now as you are waiting for the competition to start, I'll make sure that I'll be explaining some concepts which are involved in networking. So in due time we start. Let's just see what we have so far. So we're just waiting for this event, saying 4 minutes to go. I'm not sure why they have extended the time. Okay, 4 minutes to go. Let me just share this particular event also to other students so that they're able to see what's happening. Okay, so now that that's done, we can get started now. Okay, so as you are waiting for the event, now let's see some of the things for which we can talk about as we are waiting for this event to start. So first of all, let's just try to understand some few basics when it comes to Cisco Packet Tracer itself. So here I'm using Linux, so you can run Cisco Packet Tracer in Linux, and you can also run this particular application in Windows. So let's just see some of the few things which we can talk about in Cisco Packet Tracer. So here we'll start with the headers which we are seeing on top there. So we have this thing, okay, which is said press notes. So this is used when you want to give a particular comment in Cisco Packet Tracer. For example, you can type the word welcome. So that is used to give a comment. So if I want to delete this thing, I'll just select that, then I'll make sure that I'll go where it says the welcome thing, then I can just get rid of this so I can delete either way. So if I remove this, you can see everything is gone, or you can just use the delete button on your keyboard. So again, we need to talk about how we can drag a particular device. So we have different types of devices, but just to get started, I would say, suppose you have this router, you drag it there. So this router you are seeing now is what we call a networking device. Okay, so why is it called the networking device? So it's called the networking device because it acts as an intermediate between one endpoint and the other endpoint to know where to send the traffic, or let's say packets or messages from one point to another based on their network. Now networks do not just identify each other on the network as if like we do normally. People, we can just go out there and say, okay, what's your name? Okay, my name is James, so I've identified you as James. Now for networks, normally they use what we call an IP address. Okay, so an IP address in this case is what enables communication to take place on the internet. Now here we need to understand what IP address is. Okay, so before we even try to explain what IP address is, I'll give an example. So suppose you double click on this router, for which is our router. We want to make sure that we configure some things. So just a minute, let me make sure that I also share my full screen in a case whereby you want to see what I'm doing. So just a minute there, I add my full screen. Let's just call it full screen. So the competition now, just some few seconds for it to start. So to everyone who is joining, make sure you go to the lecture theater, watch this live, as you are also enjoying this particular thing. So thanks to Chikiswaga ZDM, live from Tanzania. Is that even true? Okay, so let's see. Let's share the full screen here. Okay. So okay. Okay, so now, as I was saying, in a case where you want to see where you can configure this particular IP address, all you need to do, you need to go, you double click on this particular router, and once you double click on this particular router, you see that under physical we have some few things. We have config, okay, and so on. Now for me to demonstrate nicely, I'll just write this and then I'll delete. Okay, so make sure that we delete that. Then now under network devices, I'll make sure that I drag this router, which is called pit router. So I'll double click on this particular pit router, for which I'll demonstrate. So now you can configure an IP address. So now I'll just go where it says config, short for configuration. Then you can see under interface here, we have types of interfaces. Okay, we have fast Ethernet again, we have serial and other fast Ethernets. So suppose I'm connected to Ethernet, I need to select a particular interface for fast Ethernet. Then once I do that, here where it says IP address, I'll type in a particular IP address, for example this type of an IP address. Okay, now you can see that these IP addresses, they are actually something we need to talk about, because in our case we are assuming that, okay, we don't know what is the meaning for this, what we are saying an IP address version 4, we don't even know what's a subnet mask. So let's take a simple example, as our friends are participating in this particular event. So let's just make sure we have an example we can look at, then we see how we can get started again. Okay, so let's just see, let's go under live again. We see if the event has now started. Again, they've changed I'm not sure if they are changing the time. Now it's telling me 16 minutes to start. What's happening that side, guys? What's happening? Because there's no way. I was from saying we have how many minutes? I was saying we have about some seconds to start. Now it's telling me to say we have minutes. Come on, guys, let's be punctual. Okay, so let's continue. So here let's talk about subnetting. So on your left bottom corner there, we can see we have the notepad. So let's talk about some few things. So first of all, we need to understand what is an IP address. Okay, what is an IP address? So in this case, we can say IP, short for Internet Protocol. This enables communication on the internet. So again, as we've already said, we know that networking has to do with communicating enabling communication on the internet to share resources. So that is done because of the IP address. Now, to get started with IP addresses, we need to know what we call the types of IP addresses first. Types of IP addresses. Okay, so we have two types of addresses so far. So we have the first one, which is IPv4, short for IP version 4. Then we have the IPv6, which is short for IP version 6. So these two versions for an internet protocol are the ones which are normally used. So what's an IPv4 and how does it look? Then what's an IPv6 and how does it look? Okay, so internet protocol version number 4 is the mostly common used IP version. Okay, so you see something like 192.168.10.0. So this is an example of an internet protocol version 4. Okay, now what about internet protocol version 6? Though we haven't defined it, but we just want to make sure that we give you an example about what are these IP addresses, how they look, and so on, because having an idea when you see a particular IP can give you an understanding of what you are talking about. Okay, so just a minute, let me show you an example of IP version 6, so that now we get to talk about the classes of IP addresses, then we'll start from there. Okay, so unlike IP version 4, we can see that an example of IP version 6 can look like this. Okay, now this is an example of IP version 6. So if we take a look about this example of this IP version, we can see we have numbers, then combination of letters, but this is in hexadecimal. Okay, because we know that in hexadecimal we have numbers and letters. Now in terms of the listing, it will start at 0, then 1 all the way to 9. Then instead of saying 10, it will be A up to F. Okay, so we can see that from this range we have those letters I'm talking about and the numbers. So in terms of the format, an IP version 6 happens to be in hexadecimal, okay, format. So now let's now talk about the IP classes. So we have IP classes. Okay, so for the IP classes we have class A, class B, class C, class D, and class E. Okay, now how do these particular IPs differ, and what are these IPs basically all about? So when we start with class A, B, C, and D, then E. So we need to understand what are these. So starting with class A, class B, and class C, these are just used for networking. Okay, then class D is used for multitasking. Then class E is still under development. Okay, so because as we are waiting for this particular competition, we know that what we are dealing with in our case is class A, B, and C. Why? Because today we are talking about networking. So class A, B, and C, they are used in networking. So even in this particular demonstration, we'll talk about networking classes, which is A, B, and C. So I'm not sure why these guys are just increasing the time. The event again is saying 10 minutes to start. Let me just try to get in touch with one of these guys, because I'm not even sure what's happening myself. Let me just try to get in touch with one of the people physically there and see what's the reason of them changing the time. So as we are waiting for this event to start, here we'll be getting some tips or some knowledge about what networking is, and so on and so forth. So let's just continue. Okay, so now let's talk about these classes which can be used in terms of networking. Okay, so we have class A, class B, then class C. So let's see what are these, then how they can be used. So in just a minute, I try to reconnect to my internet. Network is poor. Okay, so now we'll start with class A, class B, and class C. Now before we even begin, we need to talk about a little bit of how to solve a binary. Okay, so here let's talk about how we can solve some binaries, because this will be needed for us to understand. So in terms of binaries, we have what we call the power of 2. So suppose I want to start at 1. When I say 2 to the power 1, the answer is 1. Okay, when I want to go at 2, so here I'll be saying 1, that's the answer. So if I'm at 2, then I say 2 to the power 2. Let me even indicate the power symbol. So 2 to the power 2, the answer there, we get 4. Okay, so again we go, let's start with the power 0, by the way, sorry for that. So 1 to the power 0, we get 1. 2 to the power 1, we get 2. Then 3 to the power 2, so 3 to the power 2 there, we get 8. Now we are saying that when it comes to binary, we use what we call the power of 2, powers of 2. Why do we call it powers of 2? Because the base always will be the same, it will be 2. So for example, 2 to the power 0, it's 1. 2 to the power 1, it's 2. Then 2 to the power 2, we get 4. Then again 2 to the power 3, we get 8. Then 2 to the power 4, we get 16. 2 to the power 5, we get 32. And then 2 to the power 6, we get 64. And then we have 2 to the power 7, we get 128. Okay, so here I won't show 2 to the power 8, because when we look at this particular IP address example for version 4, we can see that we have 4 octets: 1, 2, 3, and 4. Now In terms of converting this number in binary, is the same as we have how many number of bits here. We have 8, and here we have 8 bits, so don't worry about that. To explain, even here is the same. We have 8 bits, and even here we have 8 bits. So if we have four portions, then each portion has 8 bits is the same as 4 by 8, which is giving us 32. So in total we have 32 bits. Okay, same now applies when it comes to these particular things. If you look at these particular conversions, for it to make 8 bits, we need to count them all the way to 8. So if I start at 0, which is now, I'll say 1, 2, 3, 4, 5, 6, 7, 8. You can see why I'm ending at power 7, because that now makes it 8. Okay, so that's the reason why we're ending there. Now, here we are not really interested in how we can come up with this, but we are interested in these numbers. Now we'll write these numbers, which are the answers, in reverse. Okay, we'll write these numbers in reverse. So how do we even do that? So let me just write them on top. So we'll start with 128, then we'll start with 64, then 32, then 16, then 8, 4, 2, and 1. So these are the same numbers you are seeing, but in reverse, which is 128, 64, 32, 16, 8, 4, 2, and 1. Okay, so the main reason why we are doing this is that this will help us to come up with what we call the IP address range. Okay, so that will help us to come up with the IP address range. Okay, so now in this case we'll start with class A itself. Okay, so for class A, it will be represented with the highest block, which is 128. So under 128 we'll say A, then under 64 there we'll say B, under 32 we'll say C. Okay, then because our main interest is on class A, B, and C, we'll just end from there. Okay, so that we just get the understanding of what we are doing, and we continue. So I'll get rid of this C and D. Now, if I was to start the range for class A, normally we'll start at 0. Okay, now if I say 128 plus this 0, our answer will become 128. Now, instead of me writing 128, I need to subtract a 1. Why? Because 128 is where our B will start from. So here I'll say minus 1, making it 127. Then B will start at 128. Just like that. Now, here we'll say 64 plus 128, which gives us 192. But instead of saying 192, I'll subtract a 1 so that we get 191. Then 192 will be the starting point for class C. Now we say 32 plus 192, we get 224. Now instead of me writing 224, assuming that I'm going now to D, I'll say minus 1 to get 123. So this is how we can come up with the IP address range. So as we await for our participants to start now, let's see if we have any progress in terms of the event start time. So now it's saying the event is starting in the next 30 seconds. I hope now this is not a lie, because we need to start this thing as soon as possible. Okay, now that the event is about to start, let me just wait a little bit and see if the event will actually start. Then once the event starts, we will now continue as we are waiting for the leaderboard. So let's see under live events here. So now the event is live. You can see the event is live. Now it's saying 3 teams. The teams have reduced. So the event is 2 hours. So good luck and all the best to the teams, hoping that they will do their very best. So this is the leaderboard. We have how many teams? Okay, so those are the teams. So that's the description, the prizes, and so on. So let's just do this. The event has started, so as we are waiting for these guys maybe to do 1 or 2 things on the leaderboard, we continue with our session. Okay, again, all the best to these teams. So don't know why there are just 4 of them. So now we continue. Okay, so after now we come up with these ranges, we need to understand one thing. When we say 0 to 127, we are not really saying that okay, this is the actual IP which will be given. No, because let me give you an example. We cannot have an IP address 0.0.0.0, so it's not supposed to start at .0. Again, when we say 127 dot, for example, a particular IP, this, if you can take a look up, if you take a look about this particular thing, it will show you that okay, this looks something like a local IP address. Okay, that looks like a local IP address. So again, we need to be strategic about this, because 127.0.0.1, this is a local IP address, and based on this range, I'm saying that it's 0 to 127. But which ones again we are going to exclude here? Okay, we need to understand that. So we'll exclude the 0. So let me just say exclude. So we exclude 0 and this IP address, which is for a local IP address. So the reasons are simple. We cannot have an IP address 0 dot whatsoever. No, that does not make sense. And again, we cannot have an IP address which is a local address. So our starting point in this case for the range, I can say 1 to 126. At least that is acceptable. Okay, so shout out to Cisco Labs for joining. As we know, we need to continue pushing as always. Yeah. So now that we understand at least the range of this particular IP addresses, so these ones will be fixed. They are just the way they are. So starting this session, we said an example of an IP address version 4 can look like this. Now, based on the range for which we've highlighted, we can see that 192.168.10.0 is an example of class C because it falls under class C. Okay, so now that we've understood that part, let's see. No luck. Okay, so no one so far has solved anything on the leaderboard. Is still the same. So we only have one challenge here, but this challenge is a multiple question challenge. we can see that it has 300 points. So the challenge name is "Who was the network working?" So a hands-on test of addressing, segmentation, and network resilience. So addressing is what we're actually doing right now. I'm just walking you through what is networking, what things we can talk about, and so on. And then let's see this challenge. By the way, I'm not in any team, so they're telling me team required. You need to be in a team to access this challenge. So if you thought that you are going to solve this particular challenge, nope, we are not going to do that. So let's just wait for the teams to solve that challenge. It's not our job to do that, but I'll equip you with what you need to know. Okay, so let's just put the reader board like that, then we continue with our session. Okay, so now for our session we will continue with an example now. So let's take an example of a question where we can use this. So here an example will be a class C example. Okay, now before we even go any further, we need to understand that we have what we call subnetting again. So this is just an overview of an IP address, but we also have something which we call subnetting in networking. Okay, now what is subnetting? So let's ask ourselves that question. What is subnetting? Okay, so again, from the word itself, we have two terms here. We have sub and network. So it's called the subnet. Okay, sub network. We have sub and network. Now, sub, we know from the term English, okay, English term sub, it means part of something. Okay, sub is part of something, a subset of what? So it's part of something, meaning we had a particular bigger network, so to say. Then out of that bigger network, we happen now to have a sub network. Okay, now we've already defined what is a network, because we've said a network enables devices, for example, which is a laptop, a phone, a router, whatsoever, to exchange information on a network. Now that network is called the internet. Okay, so we can see that subnetting is just the process of dividing a main network into sub-networks called what now? Subnets. So that is subnetting. Now there are two types of subnetting. We have what we call fixed length subnetting, and we have variable length subnetting. Okay, now fixed length subnetting or fixed length subnetting is also known as what? Static subnetting, or it can be called as classful subnetting. So depending on the one you'd like to call it, it can be fixed length subnetting, it can be static subnetting, or it can be classful subnetting. Then for variable length subnetting, it can be called as classless subnetting. Okay, now here this is where we'll give an example of what we are talking about for each and every type of subnetting. So first of all, we'll start with an example of fixed length subnetting. Okay, so let me see a particular example which I can give. Okay, so let's say example. So suppose right now we are waiting for this completion. Okay, so we say you have been maybe given an IP address from your ISP, then we say maybe it's 192.168.10.0. okay, then we say /24. so now we say subnet the network to meet the requirements of maybe /20. So now with this particular example, we can at least try to understand what are some of the things we can discuss again in subnetting, because it's not just about subnetting. Now you can see we have something which is called the slash, for example /24, /20, okay, and so on. So how can we subnet this thing now? So first of all, we need to understand that there are some few terms or few things we need to know. So the first thing I'm going to talk about is a binary representation. Okay, so say binary representation. So by binary representation, we are simply saying how can we represent this /20 in binary. Okay, /20 in binary. So let me just say binary representation of /20. So a slash simply means the number of ones in a subnet mask. Now we can be asking ourselves again, what is a subnet mask? Okay, so that doesn't make sense. Now let's talk about subnet masks a little bit so that we start from there. So as we've said, we have three classes. Okay, we have class A, we have class B, and class C, for which we'll be explaining in this particular case as we are waiting for our participants to try their luck in answering the questions which have been given. Okay, so now here we say, since we have class A, the subnet mask can look like 255.0.0.0. so don't worry, I'll explain. Then just to master it, we say, since in class A we have just 255 as a number, so in class B we have 2, so we say 255.255.0.0. okay, so this is for class C. So what about class B, by the way? What about for class C? So it's easier to guess because when you introduce another 255, so it will be 255.255.255.0. okay, so that's how we can say these are subnet masks. Now a subnet mask is just a 32-bit value. Okay, a subnet mask, we are saying, is just a 32-bit value. It's a 32-bit value. Now what do we mean by a subnet mask is a 32-bit value? So when starting this particular binary thing, when I was explaining, I said we have a power 0 all the way to a power 7, which was here. Okay, but when we count from 0 as 1, this will be 2, 3, 4, 5, 6, 7, 8. So we are simply saying one octet such as this number, when converted in binary, it will become 8 ones. Okay, now if we have 4 octets 4 portions, so to say, it will be 4 times 8, making it 32-bit value. So that's a subnet. Now let's try to convert this number into binary so that we get started. Now I told you when you're converting a number in binary, remember that powers of 2, say 128, then we put 64, then we put 32, 16, 8, 4, 2, and 1. In other words, we are saying 1 times 2, the answer is 2. 2 times 2, the answer is 4. 4 times 2, the answer is 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. So this is how we've managed to come up with this range. Okay. Now, since we want to convert 255 into binary, so we say, let's just say 255 in binary. So 255 in binary, we say which number is closer to 255 here. We have 128. So we put a 1 where there's 128. Okay. So that's how we are going to start. So now we need to say which number is closer to, so which number is closer now to, which number is closer to 128. So in this particular case, the number which is closer to 128, we can okay, when we have 255, we need to understand that what's the answer when we say 255 minus 28, we have 127. Now which number is closer to 127? In this case it's 64. So we put a 1, where there is 64. Okay, so put a 1 where there is 64. Now since we had 127, we say 127 minus 64 is giving us 63. So which number is closer to 63 in this case is 32. We put the 1 where there is 32. Now we say, okay, what is 63 minus 32? It's 31. So which number is closer to 31? In this case it's 16, so we put the 1. Then we come where there is 8. So we say, since our answer right now is 31, which number is closer to 31? Which number is closer to 31 after, or which number is closer to 15 once we say 32 or 31 minus 16? Because remember, if I count now, which number is closer to 15 in this case, we can see 8 plus 12, 8 plus 4 is 12, plus 2, 14, plus 1, 15. So all these will become ones. So we can see that converting 255 in binary to give us 1, 2, 3, 4, 5, 6, 7, 8 ones. Okay, so this will give us 8 ones. So as we are waiting for participants, let me just see what my guys are requesting me to do, then we'll continue again. Okay, so let's continue again. So now we see that when we convert 255 into binary, we get 8 ones. Now converting a 0 in binary, just 8 zeros. So in other terms, you can say to represent this first binary, it will look like this. 255, it becomes 8 ones. Then this 0 becomes 8 zeros, which is 1, 2, 3, 4, 5, 6, 7, 8. Then that other 0 again will become 8 zeros. Then the other last 0 will become 8 zeros. Okay, just like that. So this is how we can represent this thing in binary. We come to class B. We'll start with we have 255, so this will be, we'll represent it with 8 ones. So we have 8 ones, then another 255, again this becomes 8 ones. Then we have now 2 zeros there at the end, so these will become these zeros at the far end, just like that. Then now we come to class C. We can see that here we have 3 255s. So we say let's even have another one. So 255 will be represented by ones. Now we can see we have a single 0, so that will be represented by 8 zeros in binary. Now we come back to what's this slash. So a slash basically is what we call CIDR. Okay, so a slash is what we call CIDR. So CIDR simply stands for classless interdomain routing. In terms of definition, we can say a CIDR is just a number of ones in the subnet mask. Now there's one thing which we haven't yet talked about when it comes to a subnet mask. Now a subnet mask has 2 portions. We have what we call the network portion, and we have what we call the host portion. In this case, a network portion is that portion having a 255. So a network portion is the network identifier. It will never change. Okay, the network portion will never change, but this portion which is represented with zeros is what we call host portion, and always it will be changing. And when it comes to subnetting, our main interest is to know how many number of hosts do we need to accommodate in terms of IP addresses. So we always change the host portion. Meaning in class B, this is the network portion, then this is the host portion. In class C, this is the network portion, then this is the host portion. Now, we are saying a slash is a number of ones in a subnet mask on its network portion. Host portion, by the way. Okay, now if we look at this particular thing, if we count these ones, they are just 8. So this is a slash 8. Okay, in terms of representation, this is a class 8. Okay, now what about this one? Because we have 2 255s, we can see that okay, 2 times 8, the answer is 16. So we have 16 ones in this particular case, so it becomes slash 16. Then for this one, we have 3 portions which is having 255. So 3 times 8, it will give us 24. So this becomes a slash 24. So this is the meaning. So this is the meaning behind the representation of a subnet mask in binary. Now coming back to our question, because you have an example, how can we represent a /20? Remember, a /20 or a slash will simply mean to say these are the number of ones in a network, okay, in a subnet mask. So we'll say we have how many ones? 20. So we'll start with 1 2 3 4 5 6 7 8. We put a full stop, okay, because per octet it's 8 bits. So far we are just saying we have 8 in terms of these ones. We proceed again, 1 2 3 4 5 6 7 8 dot, meaning in total now we are having 16. 8 plus 8 is 16. We are having 16 ones. So to get 20 we need to say 1 2 3 4. So now we have 20 ones. Now because on that octet we have 4 ones, we are remaining with 4 zeros to make 8. So say 1 2 3 4, then dot. Then the last portion we just have 1 2 3 4 5 6 7 8 zeros, because this thing we can tell now to say, okay, it's a 32-bit value, but it's a /20, meaning we have how many number of ones? 20 ones. That's the meaning of /20. Now we need to represent now from binary to a standard subnet mask. So we've learned to say when we convert 255 into binary, it becomes 8 ones. So meaning representing 255, 8 ones into a decimal, it will become 255. So even this one will become 255. Now what about this one? Okay, so what about this one now? So we need to ask ourselves the question, say, what about this guy? So for this guy now, so by the way, in this question I cannot even say /20 because I'll start explaining something for class B. So let's just make it maybe 27 so that we get the idea. So sorry for that. So say /27. So I'll explain why I've changed this from 20 to 27. So suppose now we're having a /27. So if this was 20, we need to say 21, 21, 22, 23, 24. So if we include 1, 2, 3, 4, this becomes 24. So we just need 3 to have 27. 1, 2, 3. So this is /27. So even this guy in binary, it's 255. Now all we are left with to do now is just to convert that decimal thing into that binary thing into decimal now. So just a minute again, just want to check up on my team. Right, so we continue. So to convert a particular number in decimal, we just need to get this number, okay? Then what to do, we say if we have 128, then 64, then 32, then 16, then 4, okay, then 8, then 4, then 2, then 1 from the powers of 2. Here now what to do, we say, okay, here we can see we have 3 ones, okay? So we have a 1 there, and we have a 1 there, we have a 1 there, we have a 0 there, here we have a 0, 0, 0, and 0. So what to be interested in are these first these 3 numbers which are having a 1 on top. So wherever you see a 1, that's the number which you need to add, okay? So in this particular case we say 128 plus 64. So we have 128 plus 64 plus 32. So now we need to add those numbers for us to know what's our final answer. Then that will be our decimal representation of that binary. Okay, so when you add 128 plus 64 plus 32, you get 224, meaning this guy here in terms of decimal is a 224. Okay, now remember what we've said in terms of a subnet mask. We were saying this number having 255 is the network portion. It will never change, meaning we can change this 0 into anything. So we can see that this 0, which is the host portion, has now changed to 224. So meaning now we have a 224 representing /27. So going back to the question again, we are told to say we need to subnet the network based on these requirements. So we have our first thing now. So I'll just get rid of this. We have our first thing, which is called, we have a subnet mask now. So I'll say we have a subnet mask, which is equal to that. Now we need to know the block size. Okay, we need to know the block size. Now, what is a block size in this case? Before we even get started, what is a block size? So think of a block size as a container for which allows you to know the number of IP addresses you can have in a subnet. So a best example we can say is, suppose you have a number which is 5. Okay, so if you have a number 5, how many IP addresses can you have? Maximum we can have 5 again, because you can have the first subnet, second, third, fourth, and fifth. So that's how we can say, you can think of a block size. Now, a block size in this case is just a number which tells you how many number of IP addresses you can accommodate. Now, there's a way on how we can calculate a block size, and on how we can determine the block size. So before we can go to the block size, let's talk about what are subnets and number of hosts, so that you can take it up from there. So a subnet is given a formula which is 2 to the power x. So where x is the number of ones, so let me say x is the number of ones in a subnet mask. Okay, so x is the number of ones in the subnet mask. Now we have our binary representation, which you know that here we had what, /27, and we said we can represent that guy, we can represent that /27 like this. So if this is /24, we can say 24, 25, 26, 27, 1, 2, 3, 4, 5. So this is a representation of /27. Now, following this formula again, where we are saying 2 to the power x, where x is the number of ones in a subnet mask. Now, we need to say in the host portion of the subnet mask, because this guy is not of our interest, it's the network portion, it will never change. So this is what to be changing now in this case, this guy. So what to do now, we say, okay, let's consider this guy. How many ones do we have? We only have 3 ones. So the formula now, it will be more like subnets is equals to 2 to the power 3. Okay, so when we say 2 to the power 3, we get 8. So in this particular network, we can have how many number of subnets? 8. Now, because we can have 8 subnets for us to determine this whole thing, we now need to know how many hosts or IP addresses can be assigned per device. Okay, so in this particular case, let's talk about hosts. Then we'll go back to the block size. So to know the number of hosts, we say 2 to the power y minus 2. Okay, so in this particular case, y will represent the number of zeros in the subnet mask, again host portion. Okay, in the subnet mask. So again, it's simple. This is our host portion. How many zeros do we have? We have 5 zeros. Okay, so here we have 5 zeros now. So because we have 5 zeros, what we can do, we can say, okay, it will be 2 to the power 5 minus 2. Now, why are we saying minus 2? So in networking, we have 2 IP addresses which are always important. We have what we call the network IP address, and we have what we call the broadcast IP address. Okay, so in this particular case now, we will never assign a network address and a broadcast address. No wonder we are saying minus 2. So as we are still going through this particular thing, we are going to understand what we mean by network address and broadcast address. So for now, let's just calculate. So 2 to the power 5, we get 32. Then minus 2, we get 30. So meaning per subnet out of 8, we can have 30 IP addresses assigned to each. Okay, now this takes us back to what's a block size. Remember, we said a block size can tell us to know how many number of IP addresses can be assigned, okay, per subnet. Now we know what is a subnet, we know what a host, and now what about a block size? So whenever you're in class C, to know the block size, it's somehow simple, okay, because even not in class C but to other classes, you can say 256, which is the maximum expected number when you're dealing with subnetting. You can say 256 divided by the number of subnets, in this case, which is just S. So this will become 256 divided by 8, which was the number of subnets. So this will give us 32. So our block size is 32. Now, how does this even make sense with it? So I've said if you're in class C, it's simple. All you need to do, you can just say hosts plus 2. That way you know the number of block size. So if our host is 30 plus 2, this will give us 32. As simple as that. If you're only in class C, this works only in class C. Okay. So let me even say that this works only in class C. Okay, so that's how you can do it. Now that we have what we really need, in this case what we needed is just the number of is just the block size which was necessary. So we'll come back on top here, we'll say block size. So block size in this case we are having 32. So number of hosts, again in class C, a shortcut would say block size minus 2. So it will be 32 minus 2, which is 30. Then we have our number of subnet the subnet mask like that. So I'll get rid of everything here. It was just used for explanations. Then we continue now. Okay, so now that we have this, we need to know here we are dealing with fixed length subnet mask or static or classful subnet mask. Now one thing again we need to understand is that when it comes to static, it means something does not change. On that one we know something does not change. Okay, so it means in static subnetting, the block size always will be the same, the number of host devices always will be the same, and the subnet mask always it will be the same. Okay, now we need to come up with what we call the IP address range. Okay, IP address range. Now for the IP address range, now we need to start at the initial. The given IP address is our starting point. So paste that. Now we say, remember this portion will never change. It's the network portion. That's what we've said. So same applies to this first portion. Is the network portion again. It will never change. So we'll only be changing this last portion in class C, which is a 0 in our case. So now what to do, say we'll be adding the block size to this last portion. So we'll start to say 32 minus plus this 0, it will give us 32. Now we don't need to write 32 at the far end, because 32 would represent the next coming subnet. Okay, so we'll remove this guy and say 31. So instead of writing 32, we'll be saying -1. Now let's just talk a little bit about these two IP addresses. So let's highlight what we call the network address. Okay, let's highlight what we call a network address. So let me just write this in normal order so that it's easier to see. Okay, so a network address is the starting IP address. So in this case, this is our network address. Okay, because this is the starting IP address. Now what about the broadcast address? Broadcast address. So the broadcast address in this case, so I needed to do this. Let me do this first so that you are able to see nicely. So the broadcast address in this case is that last IP address which cannot be assigned, same as the network address. Now if we are saying that we can accommodate 30 IP addresses in this case, what do we mean by that? So if you see, if you have a 0 going to 31, you need to know how many number of IP addresses you have in between. So we cannot use .0 and we cannot use .30. So what are the usable IP addresses? Okay, so what are the usable IP addresses? Okay, so for the usable IP address, since these two we can never assign them, the network address and the broadcast address, we need to start at .1. Okay, and again we need to end at .30, because we cannot assign 31 and we cannot assign this 0, so we start at 1. We cannot assign 31, so we end before 31, which is 30. Now if we look at the number of IP addresses we can have per subnet, we've said 30. So we can see that we can use just 30 IP addresses in this network. Now this is our first subnet. So this is the same as subnet 1. Okay, so this is subnet 1. That's the meaning. So this is our first subnet, and based on our calculations we said we can have 8 subnets in this particular network. So there we go, we have our first subnet. Okay, so let's look at the leaderboard again. So far no one has managed to find anything. Okay, no one has managed to find anything, so let's just continue. Okay, so now let's go to subnet number 2. So just in this case I will explain well, now we can calculate all the 8 subnets because there's something we need to explain. Okay, now we got subnet number 2, so I will say 2. So remember, in fixed length subnet mask we are saying the block size won't change, the number of hosts won't change, then the subnet mask won't change. So what will be changing is the host portion, the last part. So here we ended at 31, meaning our starting point will be 32. Okay, now remember we said we will be adding this block size. So what is 32 plus this 32? It's 64. So instead of us saying 64, we say the 64 to be the next subnet, so it's better we say 63. So you say minus 1 there. Okay, so now after we do that, we now need to come to the network address. So you can see the network address is this one, so this will become .32. Then this is our broadcast address, so our broadcast address will become 63. Then now the usable IP addresses, since we cannot use .32 which is the network address, we'll start at 33. Then again, since we cannot use .63 which is the broadcast address, we'll end before 63 which is 62. So this is how our second subnet can look like. So we go to the third subnet. So for the third subnet, which is subnet number 3, again we can see we cannot change the block size, we cannot change the number of hosts, we cannot change the subnet mask because it's fixed length subnetting. So we change the host portion only. So here we ended at 63, meaning we are starting at 64. So here we say 64. Now we say what is 32 plus 64? The answer is 96. But here again I cannot say 96. I need to remove a 1 to make it 95, because 96 will be the next subnet. Okay, so once that is done, now I'll say okay, this is my network address, we can never assign it. Then this is my broadcast address, again we can never assign it, which is 95. Then once that is done, now we need to say okay, where can we start? If I cannot assign 64, it means I'll start at 65. Okay, and if I cannot assign 95, it means I'll end before 95, which is 94. So these are the usable IP addresses in our case. Okay, so that takes us to subnet number 4. Okay, so this will take us to subnet number 4. So we just continue this process until we reach subnet number 8. Then I want you to understand one thing, wonder we're just taking our time to go like this. Okay, so now here what to do, we say since we ended at 95, here we are going to start at 96. So what is 32 plus 96? So what is 32 plus 96? So let's see, 32 plus 96, we have 128. So here I will say 128. Now remember, I cannot just say 128, I need to say minus 1 to make it 127, because 128 will be the next subnet okay, which is subnet number 5. So again, you can see this is our network address, which is 96. So this is our network address, which is 96. This is our broadcast address, which is 127. So that becomes our broadcast address. Now here we started at 96, which is our network address and cannot be assigned. So here we'll make sure that we start at 97, which we can assign. 128 also is the broadcast address, cannot be assigned, so we'll make sure before that we can assign. So in this case, the usable IP addresses can range from .97 to .126. So we got subnet 5 now. So again, the question will be the same. Where did we end? So we ended at 127. So we start at 128. So I'll say 128. Now, oh, not there. Sorry. So we'll change this guy to 128. Okay. Now, what is 32 plus this 128? So 160. Okay. So instead of writing 160 there, we'll say -1, because 160 will be the next subnet mask. So that will be 159. Okay. Now here we need to say our network address, we can see, which can never be assigned, is this guy. So our network address is .128. Our broadcast address, again, which can never be assigned, is .159. So this is that. Then usable IP addresses which can be assigned. Now we need to say, since we are starting at 128, the next one will be 129, which is the usable. Now the broadcast address, we can never assign it, so before this number, that's where we are ending with the usable IP addresses, which is 158. So in this case, this is the usable IP addresses in subnet number 5. Okay. Now let's go to subnet number 6. So we are almost there now. Go to subnet number 6. Okay. Now for subnet number 6, we are simply saying to say, okay, here we ended where? We ended at 128, or we ended at 159. So we need to start at 160. Then again we say 32 plus 160. So we get 192. But -1, we say 191, because 192 will be the next subnet. Okay. Then after that is done, now we'll say, okay, let's just say this is our network address. So our network address is 160. Then this is our broadcast address, which is 191. So say 191 is our broadcast address. But since we are not assigning .160, we can start assigning a .161. But again, we cannot assign 191. We can end assigning at 190. Meaning this gives us the usable IP addresses of subnet number 6. So we got subnet number 7, which is almost which is closer to the last one. So we say, where did we end? Where did we end with subnet number 6? We ended at 191. So this will start at 192. Okay. So we say, what is 32 plus 192? So 192 plus 32, that's give us 224. Okay. So instead of me writing 224, I'll say 223, because 224 will be the starting point of the last subnet mask. Okay. So you can see that 192 is our network address, so we'll say 192. Then our broadcast address in this case is 223, so we'll say 223. Now here we'll say what have I done here? So just a minute, where did we end first of all? Okay, so here we're supposed to say 192, and then 223 there, Then once we do that, now we need to say, okay, because you cannot assign 192, this will be 193, and because we cannot reach to 223, this will become 222. Okay, so this is now the usable IP address range of subnet number 7. So we go to the last one now, which is subnet number 8, and we are going to see why is the last one based on the calculations we had done. So here we ended at 223, so meaning we are starting at 224 here. Then we say 32 plus 224. Okay, so 32 plus 224, which is 256. Now in subnetting we can never say 256. That's the maximum we can get. So 7 minus 1 to have 255. Now this time around we won't say we'll go to the next subnet, which is 256. No, there's nothing like that. So that's the limit. So our network address is 224, as you can see, so say 224. Then our broadcast address is 255, as you can see, we say 255. Then now here we cannot assign 224 because it's the network address, but we can start assigning at 225. Then again we can never assign 255 because it's the maximum broadcast address, so we can end at 224. So if your question was to come to say what is the maximum broadcast address, the answer would be 255. What is the maximum usable number of IP address in terms of range? It will be .224 in class C. Okay, so that's the meaning. Now here we've taken an example of what subnetting in terms of fixed length subnetting or static, or let's say classroom. Now what about variable length? So before we even proceed to variable length, let's take an example on how we can use Cisco Packet Tracer to visualize this particular network, so that we see now what is networking. So let's see, we just try to check out how our guys are performing. So let's just see the leaderboard if there are any progress before we go in Cisco Packet Tracer. So far nothing here. These guys are just still the same. Let's see the time. So far they've just used 1 hour, which is not, they've just used 30 minutes, by the way, which is not a bad thing. Just 30 minutes. Okay, so as we are waiting for any miracles here on our leaderboard, let's go back now to Cisco Packet Tracer. We will see how we can implement these things. Okay, so where is my Cisco now? So here now I'll use the full screen so that we see what's happening in Cisco. Okay, so now let's take a look at this question. We want to represent this question in Cisco Packet Tracer, the one we've just created. So start at subnet 1. So here I'll go in Cisco. So in Cisco, to represent these particular networks, just to make it simple, I'll represent the first subnet with 2 laptops. Okay, just 2 laptops, or 2 PCs, by the way. So I'll put 2 PCs to represent the first subnet. Then for the third subnet, I can just put 1 laptop, the third one, okay, let me say we also have we need to have a server somewhere. Okay, just doing things randomly. So let's have a switch. Okay, before that let's have all the networks. So we have 1 2 3, let's say 4 5 6 and then 7. Okay, and then the last one, let's just say 8. So we just want to see how we can represent this thing. So under network devices, let's have a switch. So for a switch, we use 2960, which is a layer 2 switch. So we can drag that switch. Okay, so I'll be explaining some few things as we are starting. So this is when I'm trying to draft this particular thing so that you can see it nicely. But for now, let's just see how we can get started. So suppose I want to start the connections. I need to go where there's a lightning symbol, short for connections. Then under connections, we have different types of cables. The first one, which is automatic, that one is used whenever you are not really sure of what cable to use. Then the second one, which is the coaxial cable or the console cable, this one is used to connect to a device if you want to configure it remotely. Okay, so this will make sense as we start doing it, but our main interest is say that the crossover or the copper straight through. Okay, so this black cable is used as to represent Ethernet, but if the devices are different, so if it's the same devices, we use this dotted one, the crossover. So let's start with connecting different devices. I'll use the copper straight through. So PC0 on first Ethernet 0 would try to connect the switch on the second Ethernet. Okay, so I'll do that. Then I'll say okay, third Ethernet will go to this next PC, which is PC1. Then I'll say okay, for this one we'll take it to maybe, okay, so maybe this is the first network we have. So let's say here we have another network, this is other network. Then I'll just continue doing that. So in this demonstration, I'm just using a single switch to represent this network, just a single switch. Okay, so far we are just assigning these ports. I'm sure it's just straightforward, something we can do. The only thing I've skipped is the first port. There's no special reason, but I just like doing that. So let's say we have these things like this. Okay, you see what we mean. Okay, so now let's make this to be a little bit maybe nice in terms of demonstration. So this will be our second network, and then our third network will be maybe there. Okay, let's just say this won't be connected to these switches. So here I'm just trying to come up with a visual which we can use. So once the design is done, we'll continue with the question. Okay. Okay. So let me just get another switch 29 skiste. So this is what I'll do now. I'll make sure that I remove these cables using this console thing. Okay, and then we put the switch somewhere there. Then now for me to connect the switch and the switch, they are the same devices. I need to use this crossover cable. So on the first port and the first port, I connect these two guys. Okay, and then now you can start. Let me just connect these randomly. Okay. So I'm just connecting these two things. So now let me make sure I try to adjust these to a particular point where they can look nice. Okay. Okay, 1 2 3 4 5 6. Okay, let me make this a single, this a single one. 1 2 3 4 5 6 7. Okay, so even this one must be just alone. Remember, we are trying to represent all those 8 subnets. In Cisco. So this is just an example. As you can see, I'm just doing things randomly. It's not an official question. No wonder I'm taking my time to try to represent these things. Otherwise, if it was just something like if it was a standard question, we could be following that particular question. So now let's do this. So let me just redo the chart. Okay, so now we have our design. So using the label, we can represent to say this is subnet 1. For example, this can be subnet 1. This can be subnet 2. This can be subnet 3, and then this guy subnet 4. Then let's go to this one, subnet 5, and then let's try to make this 6, subnet 6, subnet 7, then this will be subnet 8. So for this to make sense, I would like to use some demarcations. So I'll be using this symbol, then I'll make sure that I use which color can be better, yellow. So I'll say full color, then I'll go with yellow. Hope it will make sense. Okay, so we can start with this subnet as our third subnet, then this subnet as our fourth subnet, this subnet as our second subnet, this subnet as our first subnet, this subnet as our fifth, and then we have this subnet now 7, this 8, and then this 6. Now here we've made the mistake for this one. Let me do this. We need to make sure that it caters both laptops. So what to do, make sure that it caters for both. So this is now our representation. So we said an IP address enables communication on the networking if a device happens to be in the same network or subnet, such as maybe this subnet, which is called subnet 1. Devices can communicate. Okay, devices can communicate. For example, the IP address of 1 can communicate with an IP address of 2 or any IP address all the way to 30 because they are in the same subnet. Let's take an example. So where do we have two devices in the same subnet? So we can see that with subnet 7 we have two laptops in the same network. So we got at subnet number 7. We got subnet number 7. So the first IP address we assign is .93. Then the next one we just give it .94. Now notice that our subnet mask is .224, which is /27. So take a look at that again. So here we come in Cisco. So I'll double click on this laptop. Then I'll go ahead and say is desktop. Then we'll say IP configuration. So there are two ways on how we can configure an IP address. Static, it means we know the IP address, we want to configure it manually. Then DHCP, it means we are using a DHCP server to get an IP address, which is dynamic host configuration protocol. But in this case, I'll start explaining what is static subnetting or IP addressing scheme. So I'll paste the IP address, which is our static IP address in this case. Now for the subnet mask, we said we need to have 224. Okay. Now once we say 224, for the default gateway, let's just leave it blank because for now we didn't talk anything about the default gateway. Okay. So let me just take it back to real-time mode so that you don't see the packets there. So now let's assign this other laptop. We give it the next IP address, which is now .94, not 93. Then 224 is the mask. Now remember we said 224 is just /27. So if we put a cursor, we can see that it's truly /27. Now let's go back in simulation mode. We see if we can communicate with that device. So I'll send a message or a packet in the same subnet for this laptop trying to communicate with that laptop now. So let's pray. So you can see a packet now is being sent, unlike the first situation where we failed to send the packet. So the packet has been broadcasted but denied to devices which are not intended to do so. But a packet has been received to that device which was intended to receive that packet. packet, then it is being sent back. That's what we call a ping. So communication must be both sided. So now once the packet is returned back, we can see that it will say successful. Okay, so let's just wait for it, then I'll pause once it says successful. Okay, so notice now here is telling us to say successful, meaning this particular packet can be sent from one endpoint to another. Now let's take another example. Now we can try to see how these two devices can communicate. So in this particular case, I'll go in root time mode. Then I need to know the IP address for this guy and this guy. In a case I want to communicate with this laptop, I'll say, okay, let me know the IP address for this laptop. So double clicking on the laptop under desktop, I'll go where it says command prompt. Now on command prompt there, I need to write a command which is ping the IP address of a device. Now in this case, we want to know the IP address for this device so that we see if we can communicate with it. So I'll say IP config, short for IP configuration. Then we can see that under the IP version 4 address, we have the IP address which is 192.168.10.194. So copy that IP address, but in a case I also wanted to know the MAC address, I can say IP config /o, meaning I also want to see the MAC address, which is the physical address. So in this case, we can even see the physical address for that device. Now, what's the role of a switch in a network? So this switch which you are seeing, we are saying there are two switches. Its main role is just to connect devices in a network. Now, not just to connect devices in a network, but there's also a protocol which we call ARP, Address Resolution Protocol. Since the switch knows the MAC address of a device, but for a message to be sent, an IP address must be used. Now that IP address which we are saying it must be used, it must be mapped to its MAC address. So ARP will convert a MAC address into its IP address, or it will translate an IP address to its what MAC address, or vice versa. So that's how a switch knows where to deliver packets to the intended what device. Okay, so now we can try to do that. Since we know the IP address, we can go to the device which is trying to communicate. Then now we'll say ping and the IP address for that device want to ping. So ping is just a command used to see if we can communicate with a particular device on a network. So if you see TTL, which is short for time to live, it means you are able to communicate with that particular device on a network, which is good because that has been the entire goal for this thing. Now let's try to configure another subnet, for example subnet 1. So let's go back to the subnets. Okay, so we can see subnet 1, the IP address is .1, so we'll maintain the same .224. So suppose the first PC want to give it .1. How now can we see if we can communicate? Now there's a question here. Before we ask that question, let's configure this device in subnet 1 with that IP address which is .1, then 224. So the question is, can this device now, because it has an IP address, communicate with these other devices? That's the question. Okay, so let's try it out and we see what will happen, or what are the reasons behind that particular thing. So try to send the packet from subnet 1 going to subnet 7. Okay, then we'll see what will happen. So let's just take a look. Already we don't know what just happened. We've just seen to say failed. Here we can see failed, and it has become green. Why? So when you subnet a network, it means each subnet, for example subnet number 7, devices in those subnets, they can communicate, but they cannot communicate with other subnets in another device such as subnet 1, in another network, by the way, such as subnet 1. Why? Because they are not allowed to do so. Subnets, one of their advantages is that they bring about security. So you've seen what we mean by security. So other advantages, we talk about them as we try to progress with this question. So how can we now get rid of this barrier for which we cannot communicate with that particular device? We need to introduce what we call a router. Okay? Now, a router can identify where a network belongs to, where a particular device belongs to on a network. So a good example we can give is that, let's say we have a router just maybe at the far end. Let me see, where can we place our router in this manner? Okay, as I'm thinking of that, let's go on network devices, then we'll get this router, which is PT router. So let me just place it even here. Anyway, let me just place it there. So here now what I'll do, I'll say, okay, this router, I'll connect this router on fast Ethernet 0/0, then to this I'll connect to this switch on fast Ethernet 0/4. Now you can see that this router doesn't have an IP address. Okay, this router doesn't have an IP address. Now this router should belong to a particular subnet for it to be given maybe a particular IP address. Okay, now the best thing we can do is just to make sure that this router knows information about all these subnets. Then we can decide an IP address we can give it. So it's up to you to decide which one to give it. So before we talk about giving it an IP address, let's see how now we can power up this particular device so that now it's no longer on shutdown. So there are two ways to it. You can either use commands by double clicking on this router, then go on CLI, wait for command line, wait for this device to be up. So let's just make sure that it finishes building. Then once it finishes, we'll go on command line, then we can write some commands. Or now we can switch now this interface from red to green, which will indicate that it's up. So let's just give it some time, it's still initializing. So the main point of us adding this router is want to make sure that this router can know information about subnet 1, subnet 2, subnet 3, subnet 4, 5, 6, 7 and 8. Then these guys now, they can communicate. Okay, so that's what we try to do. So let's see if it's now up. So we go on CLI. So device is still booting. Why is it taking time? Let me try to do a fast forward. Okay, let me go to real time so that we don't waste a little bit of time there. Okay, now under CLI, you just press enter. So whenever you want to start writing the commands for Cisco, for example in a router, the first thing you can do you can simply say, let me try to zoom in so that you see what's happening there. So the first thing you can say, it's en. So en is short for enable. So you want to enable now from what we call the user mode into the privileged mode. So a greater than sign indicates that you are into the user mode. You now want to go into the privileged mode. So you press enter once you say en. And then now we can see that we have this hashtag symbol, which is indicating that you are into the privileged mode, where you have certain privileges to configure something. Now in this case, we'll say conf t, short for configure terminal, so that now you can configure this particular router based on the requirements. Now our requirements in this case, we're just trying to make sure that we make that interface up. We make the interface up, okay, from red to green. Now, what interface are we talking about? So if you remember, this router is connected to this switch, but on which port of the router? 0/0, fs 0/0. So say int, short for interface, then fa, short for fast Ethernet, 0/0, indicating the first port on the router. Now what do you want to do on this particular interface? Want to make sure that this interface now is no longer in red, but the interface should be in green. So that state is shut down, the interface is down. So to make sure that the interface is up, we need to say no, which is a negative command, then shut down, so that we bring that interface up. No shut down, no is the opposite. If we say shut down, it's going to be red. We say no shut down, it will come back to green, meaning it's up. So once I press enter, you can see that now it's changing the state from red to green. So if I was to save the configuration, I can simply say end, so that you end the command, then WR, short for do right, okay, right, meaning we save the configurations. So that's how we can turn this interface on. Now again, the question is, since we've turned this interface on, can we actually send the packet again? No, we cannot send the packet. Okay, why can't we send the packet? Because this router has no information about these subnets. For example, if I do this, I try to send to subnet 7, and then we say pray. Again, you can see automatically they are failed. Reason is simple. So what can we do now? We need to make sure that this has certain IP addresses, okay? So even to turn on the interface, if you want, you can do it graphically. So under config here, you can just come where it says fast Ethernet 0/0, the one you are using in this case. Then on that interface, you can see it's on. So the moment you turn it off, you can see it's in red again. So here, what you need to do, you can just turn it on. Okay, so that's the simplest way you can do it. Then if you want, you can give it an IP address here. Now we cannot give this guy an IP address, for example, because each IP address will belong to a particular subnet, which doesn't make sense. So what should we do? Now we have some protocols which govern communication on the internet. For example, when we go on routing, we have static, which is just short for IP version 1. Then we have RIP, which is short for IP version 2. So broadcasting, the main IP address here, for example 192.168.10.0, can simply say that this router knows information about all these networks okay, because all these networks, they belong to this main network. So if we go back on the command line, the command is router RIP, then network will broadcast the network. So if you want to save these again configurations, you can just save WR, you save the configuration. Okay, so let's just see if maybe that can help us to achieve what we are doing. So otherwise, there is a lot to know when it comes to networking, but we are just trying to keep it simple as our participants are trying to solve these particular challenges. So let's make sure that we try again and again, because whenever you make a change in Cisco, it can take a little bit time for it to work. So let's see. Then as we are waiting again, we need to make sure that we check how the competition is going. So let's see. So come back to this configuration again. So that was just a demo. So let's do this. So let's see any changes in the scores. Okay, so night gamers, they have 60 points. So these guys have actually started solving some things. Wow, interesting. So let's see some individual players who managed to solve that. So I'll just go on the global leaderboard, live CTF, and then instead of saying team, let me use individual so that I see. So okay, so under night gamers, these three participants, Jackie Joshua has managed to find 20 points. Then we also have unknown. Who is unknown? These kind of usernames are blown. So unknown again has managed to find 20 points. Then Socks Dirty again 20 points, giving this team a total point of 60. So these are the current standings in this particular team to team live CTF. So those are the current things we are seeing. So let me make sure that let me fix this so that it's just so that here you can see the scores. So night gamers now from ski state 70. So night gamers from ski state 70. Okay, congratulations to these guys. So all you need to do, you just need to register your ZCTF account. Once you register an account with ZCTF, you need to come where it says practice. Okay, so under practice there, you are going to find challenges concerning Cisco Packet Tracer. Then under these challenges which are concerning Cisco Packet Tracer, so for example, this challenge, you can try it out, you see what they expect for you to do, then submit the flag if you can find one. So all you need to do is to download the file. If there are any hints, view the hints, then you just submit the flag there. So far, how many people have solved this? I saw 5. How many people have solved this? 5. Okay, so you can also track the leaderboard directly under the leaderboards here. You just go where it says live CTF or global. In this case, let's just go on global leaderboard so that we see the all times winning champions on this particular platform. So we have Ventric at number 1, we have Zukoaka at number 3, the number 2 we have Michael Mbao. So I wonder why these guys are not even participating in this physical networking event. Maybe they are just too interested in CTFs. Otherwise, even networking is interesting, guys. So I just want to see where are those guys now, the ones who are currently participating, because I don't think I've seen them on the leaderboard before. So where are those guys? Okay, Jackie Joshua. Oh, so Jackie Joshua is even active. Why? Okay. So which one again? Which one? We have... you can forget the names. Which one? Which one? Anyway. Oh, Dirty Soak. So, even unknown, okay. So, I've seen them now. That's nice. Okay. So, that's what we need to make sure we are doing, guys. So, keep it up. At least now we can see some change in these points. So, which other team again is doing great? Only one team. Night Gamers. Okay. Okay, so for now, let's just wait to see what's happening. So just need to find out how many minutes we have in so far. Okay. So how many minutes are we having in this competition now? So far these guys have used up 50 minutes. Okay, out of 2 hours. Time is not moving. Alright, so let's make sure that we wait on that. Then again, I'll continue with writing what is this all about. Okay, so we'll continue with our networking. Let me just make sure that so stay tuned. We'll continue with VSM subnetting now. Just a minute, I need to attend to something, so I'll just unmute myself for a little bit. Okay, so let's proceed. We can see things are moving well. So congratulations to these guys so far. They are at number 1, Night Gamers. So now let's see an example of where we can use variable length subnet mask. Now take note that that's what we started there with Cisco. It's not something which is official, it's just something which I was trying to explain about IP addresses, so on and so forth. So let's see what now we can do now. Variable length subnet mask and how it can be used. So I'm not really sure how these guys that side they are dealing with time, because as far as I'm concerned is that at 16 hours the event was supposed to end. Now here I can just see that the event is ending maybe at 17 hours. So the event is ending at 17 hours. Okay, that's something new. 17 hours. Okay, so 46 minutes remaining for this event to end. So let's talk about variable length subnet mask. So let me just see. Okay, so Joshua Mutale is now on the leaderboard with 20 points, and the Night Gamers have managed to stay on number 1 with 90 points. To be honest, I don't even know how this setup is, because I was never part of the people who set up these challenges, because I'm not in campus, I'm not at school, so I'm just home when I'm doing this live broadcast, so that you can see what's happening there, and for you guys who just like to get an overview of what's happening, what is this competition all about, this is what I'm doing, just explaining some few things. Hope you enjoy so far. We've streamed for 2 hours now, so this is just a lot of time we've used. So let's see now we can do VSL as we await for our champions, and it will be a shame if these other guys they will end up with 0 points. No, let's be serious. So these are all the participants. And only 2 have managed to find something, and the rest just 0. Anyway, I hope that it works out for them. Okay, so Joshua Mutale now with 30 points, and I can see MSB Networking Innovators with 5 points now. So now at least things are making sense. People are now starting to think what's over. I don't know what's happening. Maybe they are just having the flags and wait for the right time submit. I don't know. So let's see. Let's do an example of what is VSM. Okay. So variable length subnet mask. So here let's take an example. Say example So give this example as ZCTF, let's say IT Society. So IT Society has list an IP address which is 192, or let me use class, at least class C, so that class B, so that you understand. Okay, so IT Society has listed an IP address from their ISP, which is Xamarin. Okay, they want you to help them out with subnetting based on their network requirements. Okay, so that's the thing. So now their requirements are as follows. So you know, IT Society, it has members. Okay, society members, does society members. So let's just say maybe society members are 260 hosts. Then let's say executive members, let's just say these guys are 20, so 20 hosts. Then number 3, let's say we have a way to variable length subnet mask. Here we are simply saying that the subnet mask always will be changing based on the requirements, unlike in static which was fixed. Everything we didn't change apart from the host portion. So that's the meaning right there. So again, Night Gamers, I can see now they're at 120 points. Then Joseph Mutare with 30 points, and MSB Networking Innovators, they are 5 points, and Villain Vipers, now welcome to the leaderboard, you have 5 points. So I'm sure it's tough for these guys who are just alone. Okay, so now we can even see in the society our Secretary General, Mr. Henry Mutare, is telling us to say after 1 hour 20 minutes, some people have managed to get some points there. Okay, so the guy is a little bit behind because he is showing 90 points, but you can see 120 points. Okay, so that's nice. Okay, so now let me just react to this so that they see that I'm also watching. Okay, so now we continue. So what we need to understand is that in variable length subnet mask, we need to make sure that we use what we call the VOSM table. Okay, VOSM table. Now for our VOSM table, to start with the block size, in this case we start with the block size. We'll say CIDR, then we say hosts, then we say subnet mask. So don't worry, I'll explain everything here. So we just want to answer this question. Okay, so a block size always it will start at 1. Okay, then you say 1 times 1, we have 2. So for a block size here, we can see that to be multiplying by 2. So 2 times 2, we have 4. 4 times 4, 8. 8 times 2, 4 times 2, by the way, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. So once we reach 128, it means we end there. Don't add anything, okay? Don't say 256, no, just end there. Put a 0 instead of 256. Then we go to the CIDR now. So for the CIDR, this is what we need to understand. This IP address we are given belongs to class C. Why does it belong to class C? Remember, when we started the topic, the range, class B, by the way, when we started the topic, we saw that the range between 128 to 192 is class B. And in our case, we can see that 172 is between this range, so it's class B. Now, how does the subnet mask for class B look like? So if you can remember, the subnet mask for class B, the subnet mask for class B was looking like 255.255.0.0/16. Why? Because if you convert 255 into binary, you get 8 ones. So if it's 8 times 2, you get 16. So if this is a /16, this would be 17, 18, 19, 20, 21, 22, 23, then 24. So here we start at /24. Now for the CIDR, we'll be saying -1. Okay. So for example, we have 24. 24 minus 1, we get 23. Then 23 minus 1, we get 22. 22 minus 1, we get 21. 21 minus 1, we get 20. 20 minus 1, we get 19. 19 minus 1, we get 18. Then 18 minus 1, we get 17. Then 17 minus 1, we get 16. So that's the CIDR. If you can remember, we said it represents the number of ones in a network. Okay. Now we go to the number of hosts. How many number of host devices can we have? Now, if you remember, we were calculating the number of hosts. We said to calculate the number of host devices, we say 2 to the power y, where y is the number of zeros in the host portion of a subnet mask. Okay, so this is what we said. So suppose you want to know the number of hosts for /24. So we know that the total number of bits we have, they are 32. So what is 32 minus 24? That's the question. Okay, 32 minus 24. So here what to do, we say what is 32 minus 24? So the answer is 8. Meaning here is the same as we have how many ones or how many zeros? 8 zeros. So if we have 8 zeros for this guy, if we happen to have 8 zeros, so if we say 2 to the power 8 for the formula, which is giving us 256. Now here we forgotten a -2, which is for the broadcast and the network address. Okay, so 256 minus 2, here we get 254. So those are the number of host devices we can have with that slash. Then so here, meaning the slash, here if we had 8, here we are having now 9 zeros. Here we have 9 zeros. So again we say 2 to the power 9, 2 to the power 9, which is 512, minus 2, which is 510. So here we have 510 now. So we continue. Here we have how many zeros? Okay, let me just even put I say zeros here so that you can be seeing. I say zeros there. So here we have 8 zeros. In fact, here we have 9 zeros. They will be incrementing. So here we have 10 zeros. Here we have 11 zeros. Here we have 12 zeros. Here we have 13 zeros. And then 14 zeros. 15 zeros. And finally 16 zeros. Okay. So now we'll say, what is 2 to the power 10 minus 2? Okay, so 2 to the power 10 minus 2. So it gives us 1022. So what about 2 to the power 11 minus 2? 2 to the power 11 minus 2. So it will give us 2046. So what about 2 to the power 12? 2 to the power 12 minus 2 to give us 4094. So what about 13? So 2 to the power 13 minus 2. So which will give us 8190. So what about 2? What about 2 to the power 14 minus 2, which will give us 16,382. Okay. Now, what about 2 to the power 15 minus 2, which will give us 32,766. Okay. Now, what about 2 to the power 16 minus 2, which will give us 65,534. So these are the number of host devices or IP addresses which can be assigned. Okay, so let me just look at the scoreboard again. So now on the scoreboard here we can see that Night Gamers are still stuck at 120 points, holding the first position. So they are hoping to receive a 300 quarter if they maintain this position. Then we have Joseph Mutare with 30 points at second place, hoping to get the 200 quarter if he maintains this position. Then we have Villain Vipers with 15 points coming at third position. Then we have Venomous Twins with 10 points at fourth position. Then we have MSB Networking Innovators with 5 points at fifth position. Then the last team, which is Zero Subnet, with 0 points from the name itself. Alright, so Joseph Mutare has managed now to reach 40 points. Then Villain Vipers with 25 points. So we are how many minutes behind for us to finish? So we are only remaining with 28 minutes for this competition to end. Then if that's how they turn out to be, it means that's the end of this live stream. So as we still wait for 28 minutes, let's go back to our question. We tried to finish some few things there. So thanks to everyone who managed to tap in, either just for some seconds, but maximum in this live we have 36 views, for which is not a bad thing, as it is our first time to stream live on this channel. So we've streamed for 2 hours 32 minutes now, So our stream will end at exactly 3 hours. So hoping that we'll find a way on how we can trim this thing so that other viewers can watch it not in 3 hours, but maybe just 10 minutes. Okay. So, okay, this is interesting. Joseph Mutare with 40 points is coming for the first position. Be careful, net gamers, be careful. So